Hi, in this video we will see what are the permitted operation on the rows of a matrix and what do we mean by row equivalent matrix. So as we know that any system of linear equation can be written as an augmented matrix. So whatever operations we can perform on the system of linear equations, the same operation are permitted for the rows of the matrix because each row in the matrix corresponds to an equation in the system of linear equations. We know that when we have a system of linear equation, interchanging the equation is one of the permitted operation. I can write second equation at the top and I can write the first equation as the second equation. It doesn't make a difference. I still get the same solution for my system of linear equation. So this is one of the permitted operation on the equations, and the same operation corresponds to the operation on the rows of the matrix. So each equation corresponds to a row in the matrix, and hence interchanging the equation corresponds to interchanging the rows. Yes? So the matrix corresponding to this system of linear equation is 0, 1, 3 and the constant 4. -1, 2, 0 and the constant 3, and 2, -3, 4 and the constant 1. Please note that we are writing the coefficient 0 for all the variables which are not there in the equation. Every row corresponds to an equation. So the first equation corresponds to row 1, second to row 2 and the third to row 3. And what operation have we done? We have interchanged the first and the second equation. This means that we will have to interchange the rows of the matrix. Row 1 and row 2 will be swapped. So what will be our resultant matrix? -1, 2, 0, 3, and then we will have 0, 1, 3 and 4. So here we have swapped row 1 and row 2. We have done a swapping. Please note that whatever row operation we are doing on the matrix has to be written on the side of the matrix. Okay, so this is one of the permitted operations on the rows of the matrix, that you can interchange the rows. Now let us look at the second permitted row operation. When we have a system of linear equation, we know that we can multiply any equation by a non-zero constant. It does not change the equation. It just gives us an equivalent equation. So if we have, say, the first equation, and if I try to multiply this first equation by a constant 2. Okay, so when I multiply it by 2, I know that all the coefficients and the constants gets multiplied by 2. Equation which I get is 2y plus 6z is equal to 8. This is a permitted operation on an equation. So for matrix, we can multiply a row by a non-zero constant. So what are we doing here? We are multiplying the row 1 by a constant 2. So our resultant matrix comes as 0, 2, 6, 8, -1, 2, 0, 3. Row 2 and row 3 remain same. 2, -3, 4 and 1. And what operation we have done? Let us write. So we have done 2 times of R1. We have multiplied row 1 by a non-zero constant which is 2. Okay, and the third operation is add a multiple of an equation to another equation. 2, so the equation which results is 2y plus 6z is equal to 8, and now we can add or subtract any two equations, correct? So when I try to add equation 1, let this be equation 1 and this be equation 2. So the permitted operation is that I can add equation 1 and equation 2, and I get -x plus 4y plus 6z is equal to 11. This is a very well permitted operation with the equation, and the same corresponds to the matrix also. So add a multiple of a row to another row. Okay, so how our matrix will look like? What are we trying to do? We are trying to write the row R1 as 2 times R1, and we are trying to add an R2 to it. This is our elements will be 2 times row 1 plus row 2 will give us minus 1, a plus 4, a plus 6 and an 11, and please remember row 2 and row 3 will remain same. We are not performing any operation on them. Okay, so we see that after performing all the operations, permitted row operation, this is the final matrix we are getting, and this matrix is equivalent to this matrices. Okay, so I hope the elementary row operations are clear to everyone. The first one is that we can interchange the rows. Second is we can multiply any row by a non-zero constant, and the third is that we can multiply a multiple of a row to another row. All these are permitted operation, and the matrix that results after performing this operation is called an equivalent matrix, equivalent to the original matrix. Okay, a row equivalent matrix is an augmented matrix obtained from another augmented matrix. The elementary row operations are performed on the later one. So if we have a matrix A and we perform the elementary row operations on matrix A, and we get another new matrix, matrix B, then B is called the row equivalent matrix of matrix A. Okay, I hope this is clear. What is a row equivalent matrix? Now let us see all this with the help of an example. Suppose we have a matrix A, 2, 0, minus 1, 4, 5, 6, and 3, 2, 1. Or let me make it minus 2. Okay, so I get a matrix B interchanging the rows of A. So I interchange row 1 by row 3. So I'll get 3, 2, 1, 2, 0, minus 2, 4, 5, 6. What operation have I performed? Interswapping row 1 with row 3. So B is row equivalent of A. B. Let us perform another operation on matrix A. If we multiply the row 1 by a constant, a non-zero constant, say 1 by 2, so we will obtain a matrix B. How will it look like? Let us write the operation here. So what operation are we doing on A? We are doing half of R1. We 0 and minus 1 because each of these elements are multiplied to 1 by 2, and we get the resultant matrix B. So here also B is a row equivalent form of matrix A, and the third operation which we can perform is we can multiply a row by a constant and add it or subtract it to another row. I can perform an operation which is 2R1 minus R2. So when I multiply 2 by 2, I get a 4, and 4 minus 4 gives me a 0. Here I get a negative 5, and here I get a minus 10. This is the operation which I am doing here. 2 times row 1 minus row 2. And this is our resultant matrix B. So in all these cases, B is the row equivalent matrix of row A. So I hope what are the permitted row operations is clear to everyone. And what do we mean by row equivalent matrix? If you have any doubts regarding this video, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Math Academy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.